Exam 2 review, question number 27. We have cosecant x is equal to 4, and it is in the second quadrant, and we need to find sine x over 2, cosine x over 2, and tangent x over 2. First of all, this is the formulas for half angles can be written in two ways. One way can be written as the sine square of x over 2 is equal to 1 minus cosine x over 2. This is one way, which is similar to the reduction formula, but I can always write it as negative and positive square root of the right-hand side, and I can rewrite it like that. Cosine x over 2 is equal to positive and negative square root of 1 plus cosine x over 2. So notice how I will need cosine, but I was giving cosecant. I know that cosecant is equal to 1 over sine, which means equals 4, which means sine x will be the reciprocal of 4, and that is 1/4. And it's in the second quadrant, so I'm going to create a triangle in the second quadrant. Here is x is opposite, the sine x is opposite over hypotenuse, so 1 over 4. So the adjacent is going to be 16 minus 1 square root of 15, and it's negative because this is the negative side of x. It's very important to have that. Now I can find sine x over 2. Sine x over 2, I know sine is positive in the second quadrant, so I'm going to choose the positive square root of 1 minus cosine. Cosine x is adjacent over hypotenuse, so minus square root of 15 divided by 4. Everything is divided by 2. I'm going to multiply both numerator and denominator by 4 to remove that 4 from here. So you will end up with square root of 4. Negative times negative is positive. And then the 4 is going to cancel with the 4 in the denominator. Square root of 15 over 8. Which you can simplify further. You could say this is square root of 4 plus square root of 15 over square root of 8 is 2 square root of 2. So you can definitely write it like this. Or leave it in the previous version. Next, we need to find cosine x over 2. Cosine x over 2 is the same. Cosine is negative in the second quadrant, so we're going to take the negative square root of 1 plus cosine x is negative square root of 15 over 4 divided by 2. We're going to multiply both numerator and denominator by 4 to remove the denominator in the numerator. So we will end up with negative square root of 4 minus square root of 15 over 8. And I'm going to leave it like that for now. And then tangent. Tangent x over 2 is basically, tangent is negative in the second quadrant, so this is going to be the negative square root of 1 minus cosine x over 1 plus cosine x. And I did not mention that formula here, but if I wanted to write tangent x over 2, this is negative or positive square root of 1 minus cosine x over 1 plus cosine x. So this is negative because it's negative in the second quadrant. All students take calculus, remember that. So only sine is positive in the second quadrant. Cosine and tangent are both negative. Square root of 1 minus negative square root of 15 over 4 divided by 1 plus negative square root of 15 over 4. Again, here I can multiply both numerator and denominator by 4 to get rid of this 4. So I will have negative square root of 4. Negative times negative is positive. Square root of 15. The 4 is going to cancel with 4. Remember that I am distributing and distributing here as well. So divided by 4. Negative times positive is negative. And then square root of 15. And that is tangent x over 2. Question number 28. We need to cosine 2a will be equal to cosine square a minus sine square a, or the alternatives, and also as 1 minus 2 sine square a. And I think this is the one that I need to use in this case. And then sine 2a is equal to 2 sine a cosine a. So if I rewrite cosine 2a minus 1 over sine 2a, this is going to become 1 minus 2 sine square a over, minus 1, sorry, over 2 sine a cosine a. Notice immediately how 1 is going to cancel with 1. I will have negative 2 sine square a divided by 2 sine a cosine a. Again, this 2 is going to cancel with that 2. One of these signs is going to cancel with that sign. You will have negative sine a over cosine a, which is negative tangent a over 1, or whatever. It's the same thing. So that is how you prove it. So the left-hand side is equal to the right-hand side. Question number 29. For question number 29, we have tangent, and we need to find sine 2x. We know that sine 2x is equal to 2 sine x cosine x, so we need sine and cosine. This angle x is in the first quadrant, and we have the tangent, so that is the first step. We're going to create a triangle in the first quadrant. Here is x. Tangent is opposite over adjacent, which means the hypotenuse is going to be 14 square minus 13 square. So r square is equal to 14 square minus 13 square, which is equal to 183, which means r is the square root of 183. Okay. Now, sine x, I'm going to write it in a different color. So sine x is 13 square root of 183 over 183. Rationalize. Cosine x is adjacent over hypotenuse. Rationalize that. You get 14 square root of 183 over 183. Tangent. We need sine x. Sine 2x is equal to 2 sine x cosine x, which is 2 times 13 square root of 183 over 183 times 14 square root of 183 over 183. And I'm just going to leave it like that. You can do the math later. We need to prove or simplify the expression cosine x plus cotangent x cosine x is equal to 1 over f, and we need to find that f. Okay. So right-hand side, sine x can't be simplified, plus cotangent is cosine x over sine x times cosine x. That is the left-hand side. And I factored the cotangent or wrote it in terms of sine and cosine. Now, we need to have common denominator, so I'm going to multiply the first term by sine x and divide by sine x. I will have sine square x over sine x plus cosine times cosine is cosine square x over sine x, which I can then write as sine square x plus cosine square x over sine x. I know the numerator is equal to 1, so this is going to become 1 over sine x. I know the reciprocal of sine is cosecant x. So, no, we don't need that part. So if you compare that with 1 over f of x, that means f of x is equal to sine x. And done.